Howdy, howdy, this is Mr. Potter. In our very first stack video, we talked about how we were going to do a couple of applications of stacks. And in our previous two videos, we talked about how to use two different stacks, one for operators and one for values, to perform calculations. And we were able to take any arithmetic string of integers and evaluate that arithmetic expression to come up with some final answer. What we're going to talk about in today's video is we're going to use a stack to sort values. And actually we're going to use several stacks. So when we talk about the idea of a stack sort, I'm going to be dealing with some set of numbers. So let's say I've got a source of numbers. So I've got 1, 4, 9, 2, 8, 5, 7, 3, 6. And I'm going to have two other stacks here. And the idea is that I'm going to pull numbers off, but I'm going to pull them off so that either the stack is going to be increasing from top to bottom or decreasing from top to bottom. And the idea is that, like for example here, I can pull the 6 off and I can pull the 3 off. And I can stack those on. Notice these are in order. But if I try and pop the 7, the 7's not going to work here. The problem with the 7 is that it's only going to, it's not going to be in order. So now I want to move stuff onto this other stack, and this other stack is going to have the opposite problem. Instead of increasing from smaller to larger like this stack does, this is going to be going with my largest on top and my smallest on bottom. So of these two numbers, the 3 is smaller, so I end up popping it off of this stack. And now I'm comparing these two numbers, the 7 and the 6. The 6 is smaller, so I pop from this stack. And now since this stack is empty, I'm going to keep popping from this stack until I can't pop anymore. So I'll pop the 7. And then I've got this 5, and the 5 is not bigger than the 7, so I'm going to have to start working again onto this stack. So this stack, the larger numbers are going to be on the bottom, so we're going to pop the 7, so the 7 is gone. Then we're going to pop the 6, so the 6 will be gone. Then of these two numbers, 5 and 3, 5 is the next largest, so we're going to pop the 5. Of these numbers, the thing is I can't put the 8 on here because that would mess up the order, but I can put the 3. So I'm going to go ahead and pop the 3 and place it on this stack. And now this stack is empty. This 8 can't go anywhere, so now I need to redo the order. So now we're going to pop the 3. We're going to pop the 5. We're going to pop the 6 and pop the 7. And all of those are going to end up being popped before we get to this 8 being popped. And once I pop the 8, then I'm not going to be able to go any further. So now I'm looking at either a 2 or an 8, which one's bigger. So in this one, we're going to have the 8, the 7, the 6, the 5, the 3, and the 2. And that's going to pop all of these elements. And I can't do anything with that 9 just yet. So now I'm going to pop over here. And so now we're going to have the 2, 3, 5, 6, 7, 8, and 9 getting popped off. So you can see that this is a method of doing a sort that we can get those elements in order basically by shuffling back and forth between these two stacks. And it's not unlike the Towers of Hanoi. It's important in the Towers of Hanoi for the stacks to be in a particular order, that we never end up putting a larger block on top of a smaller block. It's a little bit different because here the 4 would pop before the 3 would, then the 3, then the 2, then the 1 would pop. So it's a little bit different in that I have one stack that's in ascending order and one stack that's in descending order. But at this point, when my source is empty, I know that my list is sorted. And so now I'm ready to go ahead and print out my result. So as I pop, my answer is 1, then a 2, then a 3, 4, 5, 6, 7, 8, and 9. So this stack sort actually goes through, and in the act of shuffling numbers back and forth, popping off the elements as necessary, we end up with the sorted list. So the question is, okay, how do we actually go about coding this? So I definitely am going to need to have some way of going in one direction, say from my increasing stack to my decreasing stack. I'm going to have some method that goes from my decreasing stack to my increasing stack. And I'm going to have some type of sort method that's going to call these back and forth repeatedly until my source is empty. So that's the logic behind what we're doing. So let's actually get to some code here. So again, these are the array stacks we talked about last time. So I'm going to go ahead and create a new file. I'm going to go ahead and call this stacksort.cpp. And we're going to get this started in the usual way. So we're going to include iostream.h, not just iostream. We're going to include array stack.h, and then we're going to be using namespace standard. And in this case, because we're going to have several methods accessing the same stack, I want to declare these stacks as global variables. So I'm going to call my first stack, and we're going to be just dealing with types int called source. And then I'm going to have one stack that's going to be increasing values, and another stack of type int that's going to have decreasing values in it. So what I need, remember, is I need some way to sort. So we're going to talk about void sort. And we're going to have some list, and I'm going to need to know the length of that list, and I'll explain why when we get to our main. What's going to happen here is the first thing I'm going to need to do is to convert my list to a stack. So that's going to be my first process. I'm actually going to go through using a for loop on my list, taking the elements from my list and pushing them onto my source stack. And we'll talk about how the code for that will look like in a minute. And then while, why did I capitalize that? While not source is empty, we're going to do the following. First thing is I need to start my source. So if the decreasing stack is empty and my increasing stack is empty, in other words, this is the very first time that I'm going through the loop, then what I want to do is I want to take my decreasing stack and go ahead and push whatever is on top of my source stack. Now, this is a completely arbitrary decision. I'm just choosing to put it on my decreasing stack. But because that stack is empty, any number that I put on it is going to be in order. A singleton is always going to be in order. So once I do that, now I'm going to say else. If that doesn't work, then what I'm going to have to do is go through and move my increasing stack to my decreasing stack, and then move my decreasing stack to my increasing stack. And so what this is going to do is this is going to be that shuffling action that we talked about, moving everything on one stack to another stack, and then move everything from that stack back. So at the end, we know that my decreasing stack is empty. So I can do this back and forth, back and forth, back and forth, as long as the source is not empty. As soon as the source is empty, then we're ready to go ahead and put things back in our list. So we can go ahead and say int I gets 0, and while our decreasing stack is Actually, excuse me, I need to do one thing before I do this. The thing is, right now, this is my decreasing stack, which means that the stack that I have increasing has everything in reverse order. In other words, my smallest is at the very bottom of my stack, and my largest is at the very top. So I need to take everything off of that stack. And why do I have an extra brace there? I need to take everything off of that stack and put it onto the decreasing stack. Or I could just pop and push it onto my array in reverse order. So I could do while not increasing dot is empty, and just put everything on that array in reverse order. So I can take my array list sub, well, I'm going to need an index variable that we were talking about, int I gets 0. And so while this is true, I'm going to have len minus I minus 1, and I'll explain why that is in just a moment, is going to get the result of increase dot pop. Now keep in mind that if I have a stack like I did before, where I had 9 elements in my original list, so my original list goes from 0 to 8, this is always going to be whatever len minus 1. And so this spot is going to be the first spot that's filled. Len minus 0 minus 1 is 8. And when I increments, now my next spot is going to be len minus 1 minus 1, which is 7. And I'm going to keep going until this array is full. Now remember that this array started off as full, so it should end up full at the end. I don't have to worry about any funky stuff happening here. The only thing I do have to worry about, though, is making sure that my loop has an incrementation. So that finishes it, and it returns everything to this list variable, which, remember that arrays are pointers, so any changes that I make to the list are going to be affected in the function that calls sort. So what do we need to do here? Well, we need to write the list to stack method. We're going to need to write this move increasing to decreasing, and we're going to need to write this move decreasing to increasing function. So let's talk about this void move our list to stack. Remember that I have an int array list, and an int len. And what we're going to do is basically take everything off of our list and put it into the source stack. So for int I gets 0, I is less than len, I plus plus, and we're going to say source.push list sub I. So something very simple. So this is going to push everything onto our stack. So now what I need to do now is write those move increasing to decreasing and move decreasing to increasing as well. All right, so let's talk about this idea of moving increasing to decreasing. So void move increasing to decreasing. So the idea here is that I'm going to need to keep track of how long I need to do this. And I'm going to need to look at both of my stacks. Remember that if I'm moving everything on my increasing to my decreasing stack, I'm starting off and this decreasing stack is empty. And all of my data is either on source or on my increasing stack. And these will eventually get empty. One of them will eventually become empty because I'll take everything off of this. This one may become empty. Source may become empty if I get all the data off of it, but it may not. So what I need to do is figure out how I'm going to keep track of things. So first thing I'm going to do is I'm going to set a Boolean variable. Let me go ahead and set up a Boolean variable. So bool done gets false. And I'm going to keep going as long as I'm not done. So I'm going to do the following while I'm not done. So it's going to be a list, and I want to make sure I go through this loop at least once. That's why I'm using a do while instead of just a while. And of course, I definitely am going to have, if this is done, if increasing is empty, then I want to pull everything from source that I can, as long as it's bigger than what's ever on the top here. So if increasing is empty, then while not source is empty, and I'll talk about why we need that in just a moment, and source.peak is less than decreasing.peak, then what I want to do is take stuff off of my source and put it onto the decreasing. So decreasing.push source.pop. And then when I've done that, done gets true. So keep in mind, if my increasing stack is empty, I want to take everything off of this source. But remember we said this source could end up being empty. So I have to check, is it empty? If it's empty, then we're done. Done equals true. If it's not empty, check the top to see if it's bigger or if it's less than whatever's in here. Keep in mind, this is supposed to be in decreasing order from bottom to top. So as long as it's less than whatever's on the top, I can peel stuff off of source and put it onto decreasing. That's if increasing is empty. Otherwise, what I need to do is I need to see if source is empty. And if that's true, then I'm going to do the same thing. Then while not increasing dot is empty, we're going to peel stuff off of this. But I don't have to check to see if this is smaller than this, because this is in the right order already. So all I have to do is just peel stuff off of this. So decreasing.push, whatever increasing.pop is. So everything from here is going to end up on here. Eventually it's going to end up being 0. And then if that's true, while that's true, and I don't need these braces because it's only going to be one statement, but then I am going to say done gets true. So if one of these is empty, we peel off of the other one. That's what we did here, checking if increasing is empty. That's what we did here, seeing if source is empty. The else, what this else means is that they're not both empty. So what I need to do is I need to see, okay, of the two that I've got, which one of them is the right size? In other words, which one of them do I want to peel off first? So I want to say if source.peak is greater than increasing.peak and source.peak is less than or equal to decreasing.peak. And I'm using less than or equal to. I really should use less than or equal to here as well, just because I do need to check. I may have duplicates on here, and I can get stuck in an infinite loop if I don't take care of those duplicates. But what I'm doing is I'm saying, okay, if source is bigger than increasing, I want to take off of decreasing. I want to take off of source first. So if that's true, then I want to do decreasing.push source.pop. Else, then I want to do decreasing.push whatever increasing.pop is. In other words, I want to see which one of these is the smallest, source or decreasing. And if source is smaller, then I want to pop from source and put it on my decreasing. But if, if decreasing is smaller than source, then I want to take it off the increasing list. And I want to keep doing this as long as I'm not done. But in this case here, on this case here, I know I'm not done because I still have stuff on either or both of these stacks. So this is the logic. Let me go ahead and scroll so you can see it all in one. This is the logic for moving increasing to decreasing. I want to do the same idea to move stuff the other way. The only thing that's going to be different is my inequalities. And of course, the fact that I'm moving from decreasing to increasing. So we're going to go ahead and type that up. So I'm going to have void move decreasing to increasing. And we're going to do the same idea. Bool done gets false. And we're going to say do the following. And we're going to do the following while not done. And we're going to say if, but this time we're checking to see if decreasing is empty. And if that's true, then while not source is empty, and source.peak is greater than or equal to increasing.peak, then I want to do increasing.push source.pop. And that's going to take care of that. Notice that this code that we just wrote is very similar to what we wrote over here. The main difference is I've swapped increasing and decreasing as the stacks that we're looking at. And I've changed this inequality as well from less than or equal to greater than or equal to. And we're going to hit that else. We're going to say if source dot is empty, then we're going to check some other stuff. We're going to say while not decreasing dot is empty, then we are going to increase dot push decrease dot pop. And then of course done is going to get true. I need to make sure I put that done equals true in there, because otherwise this will go on forever. It's an infinite loop if I don't put that. So this code for the else that I've written so far is going to match what I have here for the else. Now I need to write the else for this innermost if here. So else, we're going to do that. Let me get up here. If source.peak is less than decreasing.peak and source.peak is greater than or equal to increasing.peak, then I want to say increasing.peak push whatever is in source. Okay, and again, it's just like what I have up here. Else, then I want to increase dot push whatever's in decrease dot pop. And of course, if I'm inside this latter if else, then I'm not done, because these stacks are not both empty. If I'm in this else, these stacks are not empty. I don't want to set done to true. So we're going to keep going through this loop. So this takes care of this shuffling idea that we talked about. We're going to move everything from my increasing to my decreasing and vice versa. And then we're going to move everything back to our original list. And I don't need that blank line there, or this blank line. All right. So at this point, we've got our sort written out. So what we need to do is we need to write a main to test it. So we're going to do int main. We're going to go ahead and leave it in the file this time. I'm going to create an int list, which we are going to define using the actual elements. So 1, 4, 9, 2, 8, 5, 7, 3, 6. And then I'm going to say that the len is equal to size of list divided by size of list sub 0. Now, I mentioned this earlier. I have to do this in the function that I define list, because as soon as I pass my list on, because I'm passing it by reference, the stack doesn't know the length of that list anymore. So I actually have to pass that length on. Otherwise, it gets truncated. Remember that this is just a series of pointers, and so I need to make sure that I keep track of that length and pass it on as well. So I'm going to go ahead and sort my list with len. And then I want to print out my list to see if it really got sorted. So for int I gets 0, I is less than len I plus plus, and I'm going to see out list sub I along with space. And then at the end of my loop, see out an end line. And then I want to return 0 because it's an int main. All right, so we're going to do a little test compile and make sure everything works the way we're expecting it to work. So G++, this is stack sort.cpp, and I'm going to do an out file of stack sort.exe. See what typos I made. I forgot a done equals true on line 27, and yeah, that's because line 26 doesn't have a semicolon. Yeah, putting 2 there is not going to help. No other errors? So let's try this. And notice that our numbers, we started off with our list being 1, 4, 9, 2, 8, 5, 7, 3, 6, and it just puts them in order. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try another list. If I start off with a list that's already in order, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I start off with a list that's already in order, is it going to take care of it? And yeah, it takes care of it. Similarly, if I try and take a list that's in reverse order, so let's do 9, 8, 7, 6, 5, 4, 3, 2, 1. Compile and run. Looks good. So let's do something else here. Let's try some other things. Let's do int list gets 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Actually, I don't want to put those in order, so let's do 1, 2, 3, 4, 3, 2, 1, 2, 3, 2, 1. So let's go ahead and compile this and run it. And notice what happens is it takes all of these ones. There's 1, 1, there's a second one, there's a third one. Takes all of my 2s, so a first 2, a second 2, a third 2, and a fourth 2. All of my 3s, and all of my 4s. And it takes care of them, puts them in the correct order. So this is just another application that I've got with the stacks. It's very similar to the Tower of Hanoi, which is kind of a typical example of what you would see in a computer class like this. But the Tower of Hanoi, there's thousands of examples on YouTube. I wanted to try and do something a little bit different just to see how it came out. So once again, this is Mr. Potter. Thank you for watching. Have a great day.